Why, hello there. Here's another math video made by your friendly neighborhood teacher. We're going to look at 3.2. This is outcome R3 in the course. What we're going to look at is we're going to look at quadratic functions in standard form. So this is outcome R3. And an equation, a quadratic equation in standard form, has the form y equals ax squared plus bx plus c. So we've got y equals ax squared plus bx plus c here. We want to note that a determines the direction of the opening and the shape of the graph. So it tells us whether it's opening up or down. And we say that a cannot be 0 because, well, if you look at what would happen to this if a does equal 0, we would essentially get rid of this x squared term, and then we'd be left with just a linear equation. So that's why a cannot be 0. B, this influences the position of the graph, and C determines the Y-intercept of the graph. So it's really easy to see in standard form what the Y-intercept is going to be, because this, X would be 0 and X would be 0 here, would eliminate this term, and then we'd end up with just the C, and then that gives you your Y-intercept. And the new thing in this section here, the X value of the vertex is found by X equals minus B divided by 2 times A. All right, so what we're going to do just to see and just to verify that vertex form, which is 1/4, you've got a bracket, you've got your x minus 2 on the inside here, and you've got this whole bracket here, which is squared, and then you've got your minus 3. So we've got this in vertex form right now. What we want to do is we want to get this into standard form. And the way we're going to do that is we're going to use order of operations, and we're going to expand the right side. So let's do that. If you want, you could hit pause right now before I go to the next slide and give it a shot yourself. So we have our function here in vertex form, and we want to get it to standard form. So the first thing we need to do is expand it, and order of operations says we need to deal with our brackets and exponents. So we've got 1/4 and x minus 2 times x minus 2, and subtract our 3. Our next step would be to do distributive property over the 2 brackets. So make sure you have a bracket there. X squared minus 4x plus 4, bracket minus 3. Then the next thing you're going to do is multiply the 1/4 through. So we end up with 1/4 x squared minus x plus 1 minus 3. Okay, and then we would simply simplify, combine like terms, and we notice that we can combine the plus 1 and the minus 3 together, and that gives us 1/4 x squared minus x minus 2, and this is now our equation in standard form. So we can simply write f of x is equal to 1/4 x squared minus x minus 2. So now what we want to do is we want to look at the differences between the two and look at what the advantages of each form is. And to think about this, I want you to check out the factored form of the following quadratics that we're going to do. We're going to do a couple of examples coming up, and I want you to try to determine why the x value of the vertex is minus b over 2a. And I also want you to think, how would you find the y value of the vertex once you have figured out the x value of the vertex using this right here? So we're going to do the two examples, and then I want you on your own to come back to these questions and fill in your answers. All right, so to look at this, we've got y equals x squared plus 4x minus 5, and we want to figure out what the y-intercept is. Now, we know the y-intercept is when we have x equals 0, so simply substitute in x equals 0. So I'm going to make that a 0, I'm going to make that a 0, and then my y-intercept is then I end up with y equals minus 5. So that's my y-intercept. So my y-intercept is minus 5. And if I want to state it as a coordinate point, I can say it is 0, 5. Okay, so now let's look at the x-intercept. Now, in order to find the x-intercept, if we recall, we do that by factoring. So if we can factor this, great. So let's try it. Uh-oh, I just noticed an error here. You see this right here? This x should not be in there. Okay, so now let's see. Do I have that everywhere else too? No, it's just there. Okay, moving on. We've got y equals x squared plus 4x minus 5. This can be factored, so let's do it. It is, I know I'm going to have an x and an x and a 5 and a 1. And to get a plus 4, I make this a positive and that a minus. And I end up with my x plus 5 equals 0. So that tells me that x is equal to negative 5. And also I've got my x minus 1 equals 0, and that gives me x is equal to positive 1. So my x-intercepts are minus 5 and 1. All right, now let's have a look at the axis of symmetry. So we're going to use the new thing that we just saw, which is the x value of the vertex is found by minus b over 2a, and the coefficient here is our a value, which is just a 1, and our coefficient here is our b value. So it's going to be minus 4 over 2 times 1, and that gives us an answer of an x value of my vertex being minus 2. So if you look at your x-intercepts here, which are minus 5 and 1, I want to see if you can figure out what the connection of the x value of the vertex is to these two numbers here. So think about what the connection is there to answer that question above. All right, so now we're going to look at the vertex. So far, we already have the x value of the vertex is minus 2. We don't know the y value. So how can we figure that out? Well, if we know the x value, we can simply just plug in the x value into our x's here and simplify. So that gives me y equals 4 minus 8 minus 5. So my y value of my vertex is minus 9. So then my vertex is negative 2, negative 9. Okay, so now we've run through one example. What I want you to do is go to the next question. The steps are exactly the same, and try this one on your own. And so hit pause right now, and I will reveal the solution. Well, I guess once you hit play. All right, so for this one here, we want to find the y-intercept. And to do that, if you recall, it's always the same, set x equal to 0. So here I've done that, set x equal to 0 here, multiply that, work that out, and we end up with y equals -6. Now, there's no real need to actually do this math for standard form. If you look here, your answer is the same as your C value, okay? So you really don't even need to do all that. You could just look at the equation and get the answer by looking at it. By inspection, we call it. Now here, the y-intercept is -6, and if you want to look at it as a point, this would be the coordinates. All right, so to find the x-intercept, you want to factor this. You want to set this equal to 0, essentially, and factor your expression on the right side. So factor your quadratic, and then you end up with x minus 6 and x plus 1. Set each of those brackets equal to 0, and you get x equals 6 here, and x equals minus 1 over here. So your x-intercepts are 6 and -1. So now what we're going to look at is we're going to look at how we can find the equation given some characteristics of the graph. And if we note here, we've got the factored form where it's y equals a bracket x minus x1 bracket x minus x2 close bracket. Now this is in factored form. X1 and X2 are the x-intercepts, and we just saw that on the last slide there. And we need to figure out A in order to satisfy the conditions that are given for our particular equation that we're working on. So let's have a look at it at an example right now. All right, so this first example says we have to figure out the quadratic equation for a function that passes through the point B, and its coordinates are 3 and 16. So if you just recall, that's going to be our x value, and that's going to be our y value. And then the zeros of the function are 1 and 7. Okay, so the zeros, that's our x1 and x2, and we need to figure out our a based on all the given facts here. So let's plug in what we know into this equation here and see what we get. So all I've done at this point is I've taken my two zeros here, so my 1, plugged it into this first x1, and taken my 7 and plugged it into the x2. Now I still have a y and an a and an x, so there's still more stuff I need to plunk in. The next thing we're going to do is we're going to take this 3 and we're going to put it in place of the x's here and here. And we're going to take the 16 and we're going to place it right here where the y is. And then we're going to see that we're just left with an expression, an equation with an a that we have to solve for. Okay, so now what I've done here is I've taken this 3 right here and I've plugged it in here and here. And then I've just simplified each bracket. So this equals 2. This here equals -4, and I've got my 16 here in place of the y. Now all we want to do is simplify. So we've got 16 equals a times -8 right here. And then all we need to do is solve for a. So the next step in solving for a is dividing both sides by -8. And we've got A is equal to -2. So now that we figured out what A is equal to, which is -2, we can take this information and put it back into this equation right here and get our equation. All right, so now let's figure out the rest of this. If we recall, we started with y equals a x minus 1, x minus 7, and plunk in the -2 in place of the a. And you've got your x minus 1, x minus 7 there. And we need to actually multiply this through and simplify it and get it into our standard form. So why don't you press pause and give this a try, and I will reveal in a moment. So here we have it. Now we've got the equation in standard form, and this will be your final solution. All right. In this one here, we're going to look at an example. We're going to look at an example where we have a bridge and it spans a horizontal distance of 40 meters and it has a parabolic arch. So it means it looks something like this. Okay, so there's our bridge and it goes from, let's say, 0 to 40. And we know that 1 meter from the end of the bridge, so from here, let's say that this is 1, it's totally out of scale, that this right here, the height is 1.95 meters. We're going to use this information to determine an equation that represents this parabola. And we're also going to figure out how high the arch is at the center of the bridge. So that means we're going to figure out how high it is from there to there. All right, so let's hop to it. The first thing that you want to do to look at this question is sketch the parabola with one end at the origin, just like I did here. So this is just a better diagram of the one previous. The arch spans 40 meters, and the x-intercepts here are 0 and 40. The factored form of this equation is going to be using our x-intercepts. So we've got y equals ax minus 0 and minus 40 here. So we're going to use this, and we're also going to use a point, and any point, we're going to use this point here that's given to use as our x and our y values to figure out a. Okay, so what I'd like you to do is I'd like you to actually give this a try and see what you come up with. So once we make those substitutions, we end up here. So we've got y equals a times x minus 0, x minus 40. We use x equals 1, plug that in our x's. We use y equals 1.95, plug that into our y's, and we end up with this equation right here. And the need is to solve for a. So in doing that, we need to simplify what we have. So we've got 1.95 equals a times 1 times -39, and then solving for a, we end up getting 1.95 divided by -39, and we end up with minus or negative 0.05. Okay, so now we notice we get an a value that is negative, which means that we have a upside down parabola, right? So we can take all this and plug it into this right here and plug our a value into there, and then multiply the brackets through to solve. So let's do that. Oh. So we've got y equals negative 0.05. X, I'm just going to leave that 0 off, and then x minus 40. And we've got y equals minus 0.05. Multiply your x through, so you've got x squared minus 40x. And then multiply that negative 0.05 through as well to get your answer. Got negative 0.05 x squared plus 2x. And this is your final solution. This is the equation that represents that situation in standard form. Okay, so now we're going to try to figure out how high the arch actually is. And what we need to do is we need to look at the vertex, because that arch is at the center of the vertex. And really what we care about is just the y-coordinate, because it's talking about height and it goes vertical like that, and that's the y-coordinate. The x-coordinate of the vertex is the halfway point of our parabola, and that's between 0 and 40, right? So it's actually 20 from either edge. So let's substitute this into our equation, and we get, so we're going to use x equals 20. We're going to plug it into y equals, and the equation that we got earlier was 0.05 x squared plus 2x. And when we do that, here actually, whoa, over here I should have actually written 20. So 0.05, you got 20 squared plus 2 times 20, and that gives us y is equal to, so then that's minus 20 plus 40, and that equals 20. So this tells us that the arch is 20 meters high. Okay, so you've made it to the end of the video. Congratulations, but there is still more to this section. We have a lot of more word problems to do, and we have more application questions to do. I'm going to separate these different types of questions in different videos so you can concentrate on the ones you need most help in, okay? So good luck with the homework and keep moving on.